Hi, and welcome to this video on inequalities. So, up to this point, if this is your first time seeing inequalities, a prerequisite of inequalities is that you really have to be able to solve linear equations. So, at this point, you should be able to solve, so let's say we had maybe 2x plus 10 is equal to 0. You should be able to solve this for 0. Okay, and what we would say is that we'd move the 10 over to this side by minusing 10. We'd have 2x is equal to minus 10, and then we'd move the 2 by dividing by 2, and we'd say that means that x is equal to minus 5. And this would give us an equality because it's equal. X is minus 5 and it can't be any other value. It is minus 5 in order to satisfy this equation. Now, inequalities aren't so clear-cut and they don't have just one value. So instead of using this equal sign, we have to now use the inequality sign, where this symbol means more than. We also have more than or equal to. We have less than and less than or equal to. So, the way you can remember these symbols, because you will have to know all of these, is think about it in terms of a number line. So say we had a number line here where we have a 0 here. If we had something that's more than, it points in the direction of all the bigger numbers, and so that has to be more than. Less than points in the direction of all the smaller numbers, and so it has to be less than. Okay, so what we could say, for example, is I could change this original equation and I could just make it so that I have 2x plus 10 is greater than 0. So no matter what happens, this value for x cannot give a solution to this that is less than 0. It can't give any negative numbers, but it also, because this is not equal to 0, it means that it can only be greater than 0, not including 0. Okay, so what we would say is that to solve this, we'd do the same thing, minus the 10 across, because these inequality symbols work exactly the same. Minus the 10 across, we'd get 2x has to be greater than minus 10, and then divide by 2, so x has to be greater than minus 5, which is exactly what we got. To begin with, we've now just got a different symbol in the way. And so we can treat all equations exactly the same. But now we know that in the first example here, x could only be minus 5. In this example here, x could be anything that's greater than 5, greater than minus 5. So it could be minus 5, minus 4, minus 3, minus 2, 0, 1, and then all the way off to the biggest number you can think of. And so this is what's meant by an inequality. Sometimes there's not a clear one answer to a problem. There might be multiple answers, and that's where inequalities are going to help. So while we've got this number line, one way that we can represent inequalities is by looking at number lines. So let's say, let's take an example of this x is greater than minus 5. And sometimes they might ask you to now show the inequality x is greater than minus 5 on a number line. And so what you would do, if you imagine this would all be filled in for you, but I'm just going to locate where minus 5 is, because this is your limit on the inequality. We put a circle above that to show that that's our limit. Open circle, we'll see what a closed circle means in a second as well. And it's everything that's greater than minus 5. So it's everything off in this direction, and that's your inequality. This whole thing just means x is greater than minus 5. If we wanted to do something that was maybe x is less than 2, we'd have another number line, 0 in the middle, 2 would be about here. We'd find the limit on that, and it's everything less than 2. So that would be your inequality there. Sometimes we might get inequalities with two limits. We don't always have to just start at one number. It might be that the number that we're thinking of is between these two values. And so to do that, we would just say that x fits into these two values. So let me draw that a little bit nicer. So x fits in between these two values. Let's say these values were -5 and 2, meaning that x, so if we take these one at a time, so if we got rid of this 2 for now, this would mean that -5 is less than x, and so we could flip this and we'd get that x has to be greater than -5. And then if we got rid of that -5 and we looked at the 2, x has to be less than 2, so it means that when we put these two things together on a number line, we find the 2, put a circle on that, we find -5, we put a circle on that, and the value can take any value in between -5 and 2. So what would happen if now these were not open circles, but were closed circles? And so that would be when we're just going to add this equals to symbol. So as soon as we have something more than, an open circle means that it's a limit to it, but it can't be a possible value of that thing. As soon as we add this or equals to symbol, this becomes a shaded circle, because the value can now take -5, -4, -3, -2, and so on. And it would be the same here for this symbol. This would become colored in, so the set of values for this would be 2, 1, 0, -1, -2, and so on. And let's say that I had a 1 here. I would have to color in this one, but leave the other one open. So what this means is that if I were to write down all of the values that are contained in this set, it would be -4, because remember I can't include the -5 here, -3, -2, -1, 0, 1, and 2 can be included because it can be equal to 2. Okay, so now we know how to solve linear inequalities. We know what these 4 symbols mean. We treat them in these equations exactly the same as we would treat an equal sign, but just be careful. If you start thinking of it as an equal sign, it's really easy to start writing down equal signs. You have to make sure that you're writing the symbol that is given in the question. There is one way that a symbol might change, however. The one, so you'll see in this case, it's always been greater than. If the symbol were to change, it would be because we divide by -1. If I were to take the minus over here, it would give me that it would give me -x is less than 5. Okay, that's the only way that we change the sign. And all we do when we divide by -1 is just flip the sign around. So any negative number that gets divided across, we have to flip the sign. Okay, so now let's look, if this is solving linear inequalities, we also will have to look at quadratic inequalities at some point. So let's have a look at what we would say if we had a quadratic inequality. So let's, for example, say we have the x squared plus, I'm trying to think of an inequality that would work. Let's go with 3x plus 2 is greater than 0. So this is a quadratic inequality here. Okay, so the way we would solve this usually would be to factorize it. And to factorize it, we need to find two numbers that multiply to give you 2, but add to give you 3. And those two numbers, in this case, would be 2 and 1. So we're going to have this factorized to be x plus 2 and x plus 1. And that whole thing is greater than 0. So what we've said before is that we can treat these inequality symbols as if they were equal signs. So that's what we're going to do. So we're going to say that in this case, x plus 2 would be equal to 0, or x plus 1 is equal to 0. And then because of this, we can solve this. So this is x equals minus 2 and x equals minus 1. But remember, these would be our solutions, but now we have to introduce these symbols. Now, to do that, we can first sketch a graph of this to try and see where our solutions are going to lie, or where our inequalities are going to take place. So we know that it passes through x equals minus 1, which I'm going to say is here, and it also passes through x equals minus 2, which is here. There's a positive in front of the x squared, which means that this is a happy face. It's going to do something like this, and we know that all of the solutions to this are the ones on the y-axis. So this is your y, and this is your x-axis. All of the solutions would be on the y-axis, and if we know that all the solutions to this are greater than 0, then it must be everything that goes above here. And if we're solving for x, everything that goes above here has to be greater than minus 1, which would be our first inequality. It'd have to be greater than minus 1, but it'd also have to be less than minus 2. Is less than minus 2. And these are our two solutions to this quadratic inequality. Now, the only way that we could have something that would go inwards and be in between minus 2 and minus 1 would be if I were to write that x squared plus 3x plus 2 is less than 0, because then we'd look on the y-axis and we'd see that those solutions would all be in the negatives, which are all less than 0, and so it'd have to be everything in between this gap. So the solution to this would be written as x is in between minus 2 and minus 1. So that would be the solution for if it was less than 0, and these are the solutions for when it is greater than 0. So that's all of inequalities that you'll have to know. So we've gone through the content of inequalities. We should now be familiar with how we solve inequalities, what all of these symbols mean, how we do linear inequalities and how we do quadratic inequalities. And now we're going to have to go through some practice questions. So we have a couple questions here that are going to start off with relatively easy, maybe the start of a paper, and then we're going to get gradually a little bit harder towards the end of a paper. So let's start off with this question. So we've been given that n is an integer. So integer meaning that it's a whole number. So it has to be like 1, 2, 3. It can't be like 0.5 or 0.7 or something like that. All the possible values of n. So n is between minus 3 and 4, but it's not equal to minus 3 and it's not equal to 4. So we have to think of all the numbers between there. So that's just going to be minus 2, minus 1, 0, 1, 2, and 3. Making sure we don't write 4 and we don't write minus 3 unless we had little lines here. If we had little lines there, it would be equal to, and then we'd include both of those as well. Okay, so this is 2 marks, would be at the start of a paper usually, and is pretty straightforward. So let's have a go at something a little bit more complicated. So the first part of this is going to be the same. We do have a line underneath here now, so we can include the minus 1, but then it's going to go up to 1, 2, 3, but not including 4, because 4 is not equal to n. Now this representation of inequalities we also looked at. If we had 2 of these limits, we always said x was in the middle and between these things. We said if it was an open circle, then it just stays as a inequality. If it's a closed circle, it also becomes equal to. And we put our limits, so our lower limit is minus 4 and our upper limit is 3. So this means that x can take any value between minus 4 and 3, including 3. So it would be minus 3, minus 2, minus 1, 0, 1, 2, 3, but not 4. Okay, so now we're going to solve this linear inequality. So we're going to solve it exactly as we would if it had an equal sign. And so we're going to say that 3y, I would move the 2 over to here, is equal, and when I move the 2, I'm adding 2, so this is going to become 15. And then y, this would be a greater than sign. It's very easy to slip into writing them back. And then y would be greater than 15 divided by 3. When I move the 3 across, it becomes divided because it's 3 times y on this side. And this means that y is greater than 5. And that would be our answer for this inequality. Okay. Now we're going to have a look at solving a quadratic inequality. So we are familiar with how to solve quadratic equations, and this is going to be no different in terms of your method. It's just going to be different in terms of the answer we're going to get at the end. Okay, so first step is we want to make sure we have a quadratic expression. So we need to make sure it's in the form of maybe an ax squared plus bx plus c. So we want to expand these brackets first, and we'll see that we get x squared is greater than 3x plus 18. And then we want to move all of this onto this side, and when we move it, we're basically minusing both of these things across, so it becomes x squared minus 3x minus 18 is greater than 0. And then we want to factorize, because now we've got this quadratic expression and it's got 0 on the other side. We can factorize and begin to solve. So we're looking for two numbers that multiply to give minus 18. I'm looking for two numbers that add to give minus 3. And that's going to be minus 6 and plus 3. So x minus 6 and x plus 3 is greater than 0. And then we said we're going to solve these individually, so it would be x minus 6, and now we're going to put back in the equal signs to get a solution. It would be equal to 0, so that means that x is equal to 6, or x plus 3 is equal to 0, which means x is equal to minus 3. And then we said we're going to sketch it to see where our limits are going to be, and this is your y-axis, this is your x-axis. So we had x equals to 6, so if we have a 6 here, it's going to pass through there, but it's also going to pass through this minus 3 here, and it's a positive, so it's a happy face like this. It doesn't have to be accurately drawn, as long as you're getting the idea that when we have this greater than symbol, we have to then say that maybe our solutions are going to be everything that gives a y value that's greater than 0. So these expressions mean that if we want something that's greater than 0, it can't possibly be in between these two values, because that would give you a y reading of a negative, and that would be less than 0, and so this wouldn't really be true. So we have to take them on either side, so it needs to be everything this side of being 6, so x has to be greater than 6, and it has to be everything this side of minus 3, so x has to be less than minus 3, and these are our two solutions to this equation. So as long as x is greater than 6 or x is less than minus 3, then this equation will be greater than 0. Okay, and finally, we're going to take a look at this question. So they've given you a rectangle and a right angled triangle, and they've said they've given you the dimensions of both of these things and said that all measurements are in centimeters, and the area of the rectangle is greater than the area of the triangle. So I'm going to write that as the area of the rectangle is greater than the area of the triangle. Okay, so working out the area of a rectangle, I'm just going to multiply these two together, so it's just going to become x minus 1 times 3x minus 2. That's going to be greater than the area of a triangle, which is a half times the base times the height. So that's going to be a half times 2x times x. So when I expand these brackets, I get a 3x squared minus 3x minus 2x and then plus 2 is greater than x squared. Okay, for those of you who struggle with expanding brackets, here I've just done x minus 1 and 3x minus 2, and I followed the rules of FOIL. So I did first, so I multiplied the first two to get me 3x squared. I did the outer, probably not in this order, that would give me the minus 2x from over here. Then I did the inner, so the 3x times the minus 1, which gives me minus 3x from here, and then the last, which gives me minus 1 times minus 2, which gives me a plus 2, which gives me this here. And on this side, the half and the 2 cancel out, and so I'm just left with the x squared. And now I can rearrange this to make it into a quadratic equation. So I'm just going to minus the x squared across to here, and I'm going to get 2x squared. I can simplify this to minus 5x plus 2 is greater than 0. And now I want to solve for this. So in order to solve this, I'm going to set it equal to 0 and I'm going to factorize. But my factorization for this is going to be a little bit more difficult than how it was before, since there's a factor of 2 in the front, so we can't really employ the same method. We're going to have to choose another method. So 2x squared minus 5x plus 2 is equal to 0. This is as a side note, just we're trying to solve for the limits of this equation. So usually we would say we want to find two things that multiply to give you 2 and add to give you minus 5. But now that we have a 2, what we're going to say is we take whatever's in front of this x squared, we multiply it by the last number, and this becomes, we need 2 numbers that multiply to give you 4 and add to give you minus 5. So that part is going to stay the same. And the values for this are going to be minus 4 and minus 1, since if we added minus 4 minus 1, we'd get minus 5, and if we multiply them together, multiplication of 2 negatives is going to give a positive, and so we get positive 4. And so what I'm going to do is split this minus 5x into these two numbers. So I can rewrite this as 2x squared minus 4x minus x plus 2. And now I'm going to put an invisible halfway line, and I'm going to factorize the first part first. So I'm going to take out a 2x, and that becomes x minus 2. And I'm going to factorize this side, and I'm going to take out a minus 1 and have that become x minus 2. And the way to check that you're doing this right at this point is that this x minus 2 and this x minus 2 must be the same. And so that factors out to be one of them, and the 2x minus 1 factors out to be the second bracket. So 2x minus 1 multiplied by x minus 2 would be equal to 0. And so if 2x minus 1 was equal to 0, this would give an x value of a half, and if x minus 2 was equal to 0, it would give an x value of 2. Okay, now we have our limits. We can draw a sketch again, so we can say, let me draw this a little bit over here. The limits on this are x is a half and x is 2, and this would be, try and make that a little bit more accurate. This would be your kind of quadratic that you'd get, and because this whole thing is greater than 0, it means that we have to look at everything greater than 2 and everything less than 1/2. Okay, so then solutions would give us that x is less than 1/2 and that x is greater than 2. And most people will tend to stop at this point and say, okay, these are my possible sets, but we have to go back to the question and just make sure these things work. So if we were to put in an x is greater than 2, we're always going to get a positive answer for all of these things, okay? And that's completely fine. as soon as we go less than a half, we're eventually going to get to negative numbers. And if we're looking at these values of x, these are an x and 2x, and even these x minus 1s and 3x minus 2s, all of these things will eventually become negative if we allow it to be x is less than a half. And in fact, if we look at this x minus 1, if we were to say it was a half and put it in here, it would be a half minus 1. And so this length, if that was the case, would be minus a half centimeters. And we know we can't have negative distances, which means that actually this can't be a solution to this, because these are all distances. We can't have negative distances. So really our solution is that x has to be greater than 2. Okay, hopefully that is all okay. If you have any questions, as always, drop them in the comments, and thank you for watching.